This problem is weird. It wants you to find how fast x is changing. This problem is weird. It wants you to know how fast is x changing with respect to theta when theta equals pi over 3. This is what it means to say how fast is x changing when theta is changing, or when theta is a certain value. So what do I want to do first? I need an equation that relates x and theta. Well, we've got the sides of a right triangle. This is indeed a right triangle, and we have an angle theta. Notice that the sides involved with this angle are the opposite side and the hypotenuse. So opposite over hypotenuse, that would be sine. So sine of theta equals x over 18. Because I want dx d theta, I'm going to isolate x by multiplying both sides by 18. So I have 18 sine of x equals, sine of theta I should say, so this is a theta now. 18 sine of theta equals x. And now that I have x by itself, I'm going to take the derivative of both sides, this time with respect to theta. Now you might be accustomed to taking the derivative with respect to x, and so when you encounter this derivative, you might say, oh, the derivative of x is just 1. No, this is going to be dx d theta. And this is why I was saying this is kind of weird, because normally you and I say the derivative of x is just 1, but this time we're taking the derivative with respect to theta. And what that means is theta is now our x value, so to speak. The derivative of 18 sine of x will be 18 cosine of theta, and then I can safely plug in pi over 3. Cosine of pi over 3 is 1/2. 1/2 times 18 gives me a final answer of 9.